Hey guys, welcome back to my channel. Thank you very much for joining me. In today's video, we'll continue on chapter 8 where we speak about our residual, our least square regression line, and our linear model. So in chapter 8, or 7, you were introduced to creating your scatter plots and describing the relationship between the variables, whether they're correlated or they're associated. So when it comes down to what is my line, it's the straight enough condition that they're focusing on to see, is it straight enough or is there a curve in your data, or the trend is positive or negative. So when it comes down to residual, least square regression line, and the linear model, we first need to understand a few things. So we can model the relationship of a line in the form y equal mx plus b. You could also see y equal bx plus a, or a plus bx. Our goal is to be sure that we're able to identify the slope wherever we see it. And we mentioned that whatever coefficient of x, that's going to represent our slope. So right here, m, b, and b represents our slope. So these are our slopes. So regardless of where they are in your equation, once it's a coefficient of the x term, it is the slope of the equation. Whatever you see standing on its own, meaning, oops, that's not writing, okay, meaning b, a, and a, we say those represent the y-intercepts. Alright, and the y-intercept, you know, is basically your starting point or the initial point of your graph where the line crosses the y-axis. So right here represents your y-intercept. Alright, so we also need to know a few things about the x values and the y values. We know the x values are called the explanatory variables or the independent variables. The y values are called the response variables. So in previous classes, we spoke about these and how they impact your variable when it comes down to correlation and association. Alright, so once you have your equation in the form y equal mx plus b, you should be able to tell the relationship between the variables, if the straight enough condition is met or not. You can also talk about the direction when you observe a scatter plot. You can also talk about the form, which is linear or not. We can talk about the strength, is it moderate, weak, or is it strong? And we can talk about the outliers, if any is available or any is there. When it comes down to the condition, we speak about if they're quantitative variables. We also talk about the straight enough, and again we mention the outlier to see if it's there. Alright, so once we are doing this, we now can introduce the model, which is your straight line or your line of best fit that goes through the middle of your data. So I like to speak with images. So if you have your scatter plot looking something like this, we can create a model right here. So your Desmos graphing or a ruler would be the most appropriate thing to do. But I'm going to try to figure a line in between the middle of this graph here. Okay, so this green line you see here would be considered to be my line of best fit. And this line should go through half the data where you have equal amount of data values on either side of the line. Alright? And from this we can form our least square regression line, which is basically known as line of best fit, comes from your linear model. So right here, this green line here tells you what the model predicted compared to whatever the actual values are. Alright? So from that, we now can come up with what's called the residual, and that's the error made by the model. I will not read this verbatim because it doesn't make any sense. Whatever I said before, it makes sense, but whatever I said before is also within this slide. So the residual is basically the error the model made. If I should go back to the previous slide, you can see that for each of these points, the model can either be accurate, it can be overestimating a point, or it can also be underestimating a point. How do you tell that? So with overestimating a point, you realize that if the actual data value, so let's say the y value is 15, so the actual value may be 15. If it's overestimating, means it's going to be a bigger number than what it actually is. So the prediction that the model made is denoted by y hat, and that could be, let's say, 20. So right here you see the actual value. For example, this point could be called 15 for y, and the model predicted this point to be 20. So it overestimated this point, so the actual estimation for the model is where the line is. So very soon we'll learn some more about that. So just keep that in the back of your head a little. Alright, so with your line of best fit, we come with the residual, and for the residual, this is the left off of that the model made, denoted by the letter E. So as I was saying to you, once the model didn't make an accurate prediction, you realize that either data values are above the line, below the line, or directly on the line, and these are known as the residuals. So they're basically the left off whatever the model error the